So in this video, what we're going to do is to derive each of these three rules for logarithms from the basic idea of what a logarithm is, and I'm going to briefly talk about how the rules can be used and some common errors that are made and how to avoid them. So the first rule for logarithms says that if you're adding two logarithms together with the same coefficient in front, then this is equal to the logarithm of the product of the arguments here, a and b, multiplied together. The next rule says that if you have a logarithm and then you subtract another logarithm from it, this is equal to the logarithm of this a divided by b. The minus sign here puts this on the bottom. And finally we have the equivalent of this rule here, that the logarithm of a to the power n is n times the logarithm of a. So you can imagine a to the n means a multiplied by itself n times, as in here, a times a times a times a, and this is equal to adding it together n times. So this is really a generalization of this rule here. And these are the only three rules for simplifying logarithms, and these are the ones that we're going to now look at. So I'm going to move on to the next slide and we're going to derive this rule here. So to show this rule for logarithms, we have to be a little bit more explicit about the base of the logarithm. So here I'm assuming that we're using logarithms to the base e, which we could also write using an alternative notation as logarithm to the base e of a is the natural logarithm L followed by an n, we just pronounce it log or natural log of a. And we have to be explicit about the base, but these rules are true for any base as long as you're consistent about using the same base in all terms in the rule. So what I'm going to do is I'm going to assume that capital A is the base e to some particular power, which I just call little a, and I'm going to assume that b is the base e to a power which I'm going to call little b. So if we do this, then from the definition of the logarithm, so from the definition of a logarithm, the logarithm to the base e, the natural log of capital A, is the natural log to the base e of e to the little a, and that from the definition is just going to be little a. So I'll just make a little bit of room and write that. So similarly, it follows that the logarithm to the base e of b is the logarithm to the base e of e to the power of little b, so that is therefore going from the definition of the logarithm to be little b. And from the rules for powers, we have that the logarithm to the base e of a times b is the logarithm to the base e of, now we have said that a is e to the little a, b is e to the little b, so a times b is e to the little a times e to the little b, so that's going to be e to the little a plus little b, so this is going to be little a plus little b. So we've now been able, with this assumption here about how we can write a and b, and that's always going to be possible to write them in some way like this, as long as a and b are positive, of course. Then we know how we can write the logarithm to the base e of capital A. It is little a, we've seen that here. Logarithm to the base e of capital B is little b, we've seen that here. And now we have seen that on the other side, logarithm to the base e of a times b is little a plus little b, so that is indeed the logarithm to the base e of capital A plus the logarithm to the base e of capital B. So we have proven this rule. So I'll just make a bit of room. So therefore, logarithm to the base e of capital A plus the logarithm to the base e of capital B is the logarithm to the base e of A multiplied by B. And that is the first of the three rules for logarithms proven. So we'll now move on to the next slide and look at the next rule. So we now want to show this second rule for logarithms, which is very similar to the previous one, except where we previously had a plus sign and here multiplied, we now have a minus sign and here we divide. Again, we're going to assume that we can write a, the argument of this logarithm, as e, the base of the logarithm, to a power which we're going to call little a, and capital B we're going to write as the base of our logarithm to the power little b. So from the rules for logarithms, or sorry, rather from the rules for powers, so from the rules for powers, a divided by b is e to the a over e to the b, and that is e to the a minus b. So therefore, the logarithm to the base e of a over b is going to be the logarithm to the base e of e to this power, and of course that's all the logarithm is asking you about, what is that power? So this is going to be little a minus little b. So it therefore follows that we can write logarithm to the base e of big A minus logarithm to the base e of capital B is logarithm to the base e of A divided by B, because we have underneath here, this would be from here in here, we would have little a. Here we would have, using this, substituting it into here, little b. So we have a minus b, but we have just shown that the logarithm of a over b is little a minus little b. So we have proven the rule. So that is the second rule for logarithms which we have been able to show. So on the next slide we're just going to show the next rule. So finally, what we want to show now is this final rule for logarithms. The logarithm to the base e of a raised to a power n is n times the logarithm to the base e of a. So to do this, if we are going to write a to be e to some power little a, from the rules for powers, we can substitute a to the n, and it's e to the a all to the n, and that just tells us that we need to multiply these powers together, so it is e to the a times n. So therefore the logarithm to the base e of a to the n is the logarithm to the base e of e to the a n, so it is therefore just this power here, so it is just a times n. So therefore logarithm to the base e of a to the n is n multiplied by little a, but that is the logarithm of capital A with using the base e. So this is n times the logarithm to the base e of capital A, as we wanted to prove. So in the previous couple of slides we've shown how these three rules for logarithms can be derived. I've been using the base e, but there is absolutely nothing special about the base, and if I'd replaced e by 2 or 10 or any other value that you might wish to use, they would follow in the same way. Of course, logarithms to the base e, the natural logarithm, are the one that we use most in mathematics. So finally, what I want to do on the last slide is I want to look at a couple of examples of using these rules and just to point out the most common slips that people sometimes make. So I've written two of our rules for logarithms here, and here is an example: 4 log x plus 2 times the logarithm of x plus 2. And when we want to combine these to use presumably this rule, since there is a plus sign here and a plus sign here, what we have to notice is that the numbers in front are not the same. And if the numbers in front are not the same, we cannot use this rule. So what I'm going to do is I'm going to say that this is equal to, and I want to have, say, 2 times the logarithm of x squared plus 2 times the logarithm of x plus 2, where I've used the third rule, that the logarithm of a to the n is n log a. So what I've done is I've written 4 as 2 times 2 and taken one of the 2's into here to write this as 2 times log x squared. And now we have the same number in front of both of these logarithms, and we can use this rule safely. So let me just make a little bit of room. So therefore, what we have is that 4 log x plus 2 times the natural log of x plus 2, should put a modulus sign really, it's got to be positive, is equal to, and now here we have a common factor of 2 that we can pull outside. So this is going to be, I'm going to do this in 2 steps slowly. So this is 2 times the logarithm of x squared plus the logarithm of modulus of x plus 2. So this is now 2 times, and now I can clearly use this rule here. So it is 2 times the logarithm of the modulus of x squared multiplying x plus 2, close the modulus. So that's our final result for how we can combine these two terms into a single logarithm. And we've seen that the point we had to be careful about was to ensure that we make the same coefficient in front of both terms so that we can use this rule here. So in the next slide I'm going to use a final example. So again, I've written out 2 of the rules for logarithms, the 2 that we're going to need here, and here is the final example. And if we look at this, we see that we're subtracting this logarithm from here, so one might think that one should use this rule here. But what we need to realize is that there's actually a minus sign in front of this one as well. So what we really have is 2 minus the logarithm of the modulus of 1 plus x, and I'm going to open the brackets here, and I'm going to add, therefore, the logarithm of the modulus of 1 minus x. And this is exactly what we've written here, and this use of brackets makes it absolutely clear that really these logarithms are adding together. So therefore, this is equal to 2 minus, and then it is the logarithm of the product of the arguments following from this. So we have the modulus, or the logarithm of the modulus of 1 plus x multiplied by 1 minus x, and 1 plus x times 1 minus x is 1 minus x squared, close the modulus. And that is our final result for that. So what we've seen in this video is that there are 3 rules for logarithms, the 2 that I've written at the top, and also the rule that the logarithm of a to the n is n times the logarithm of a. And these are the only three rules for simplifying logarithms and the only ones that we can use. And we've also seen that we've got to be careful, as so often in mathematics, about minus signs in examples like this. Okay, we'll stop there.